Am I audible now? Am I audible now? No. Okay. So here today, actually yesterday I have not sent you some programs on structures. Why I have not sent you is I am just compiling some all the topic programs for you, and then I will share it just within couple of days. Okay. So today, before starting some linked list and all, what I'm going to do is some small topics are left which are very important for interview point of view. So we will do that, and after that we will start some other topics. These are small topics. Okay, like already we have seen one static keyword. Like that we have some other keywords like constant we have. Other than that we have one more topic left which is enum, and in structures we are left with structure, bit field. So we will see all those. Okay. So we will start with your all these topics, and then we will see if at all, if time permits, we will go with linked list today. Otherwise we will wait for tomorrow. Okay. Let's start with enum first. So what is this enum is? I'll give you all the programs topic wise. Okay. Sorry, it got stuck. So here, what is this enum is enum is also one type of user-defined data type. Okay, and whatever we assign here are all numbers. Okay, generally what we are trying to do is we are trying to name the integers. We are trying to name the integers. So what will be the declaration of this? I'll show you. So here the declaration for this will be enum, and then we will just give here enum, a name to your enum. We can say something like enum underscore name, and then we will give here enumerators, we call it, or we can say number elements. Okay, so here we give all enumerators, enum name and enumerators. For example, we can say that a week. Okay, so here we have enum week, and thereafter what we will do, whatever week we want to have, we will give days, weekdays. You can say we have Monday, Tuesday, Wednesday, and so on. Whatever we want to give. This is the declaration for your enum. Now, what happens when you execute this? We will see that in a program. But this was just a declaration part, that how you declare the enum. So basically, when you say Monday, Tuesday, Wednesday, this will not print Monday, Tuesday, Wednesday, but what it will print we will see now. If at all, if it is not audible or my screen, if screen is not visible, just tell me. I have started recording already, but if at all, if it is not visible, then you tell me. Okay. So here we go with your program. So once we start with this, it's simple topic. Today whatever we are going to do, all are very simple things. So we will declare the enum. We will declare enum like we are declaring structure or union. We will declare this week, and then we will just write here all the week days: Monday, Tuesday, Wednesday, so this is our declaration part, and now in our main function, what we are going to do is we are simply going to print this enum. Okay. What we are going to print enum is we are going to print this enum using printf again. So here we don't have anything other than this printf. All are, as I said you, these are just integer constants. Okay. So what we are going to do is we are going to print it using percentile d. So as we have 7, I'll just write percentile d 7 times. In, and now just I'll copy this Monday to Sunday again. Why? Because these are my elements. So I'll simply copy this and I'll try to print this. So basically what we are trying to do is here why we use enum is because it just gives meaningful terms to your numbers. Like if you have pi value as 3.14, so rather than writing every time 3.14, if we declare some different pi values like that, if you have some more values, you can declare it using enum, and then it will simply, by using the name, we can access it. Okay. So if we print it now, okay, there is an error, compilation terminated because stdio.h I have written there's a warning. Why? Because I have not given any return type to main. It has to be int main or any defaults to int main. We have not given, that's why we are getting that. No problem. And if you see this, it has been numbered from 0 to 6, and it is not printing anything like Monday, Tuesday, Wednesday. So basically, we are giving names to your integers. Now, we will just make some changes to this enum program, and we will see how it is working. Okay, this was one basic idea of your enum. Now, can I give some numbers here? like I want to declare something. Okay, so here I give like basically what Monday is starting from 0 and the last one is whatever number you give minus 1, because we have declared 7 days, that's why we are getting 0 to 6. Suppose here I want to give some number to your declaration, so I am starting with something like 10. Okay, and then Tuesday I am giving something like 15. Wednesday I am writing like Monday plus 2. Okay, and rest of it I am not saying anything. Now, what it will print? Will it print like 10, 15, Monday plus 2 is 12, and after that 4, 5, 6 or 3, 4, 5, 6? Let's see. No, it will not print that, but let's see what it will print. Okay. Now, if you see, it is 10, 15, 12, 13, 14, 15 and 16. Now, why this happened is because if at all, if you are giving any values here, okay, then it will print those values and the next value will be the previous value plus 1. So, here we have given 10, 15, it printed nicely. After that, here you have Wednesday, Monday plus 2, which is 10 plus 2, which is 12. After that, 13, it will be added 1 and it will be assigned 13, 14, 15 and 16. Okay, so whatever value you give, the next value, even if here, if you don't give any value to your Tuesday, then also you will have 10 and then you will get 11 there. Okay. So it doesn't matter, wherever you want to assign the value you can assign, but the next value will be previous value plus 1. Now if you see here the value of 15 will be changed to 11. Okay, 10, 11, 12, 13, 14, 15, 16. Okay. One more here thing we have to see is, now can we assign two different numbers to same enumerators? Yes, we can. Now I am writing Tuesday is also equal to 10. Monday is 10 and Tuesday is also 10. Yes, this will also work. That means same values can be assigned to different enumerators. If we compile this should work perfectly. See, 10, 10. Yes, we can assign different values to same. Now, can we just utilize only one value, or can we only print one value? Yes, we can do that also. So how to do that is, now I am printing all this, and after that what I want to do is I want to take one variable. Okay, now this is called enum variable. Till now we were using this whole thing, and now what I want to do is I want to take enum variable and want to use only some of the members of this week. Okay, so here what I can do is enum week, and I'll take one variable called day. Enum weekday, like we are declaring struct, account, person 1, person 2, like that you can declare enum variables also. So enum weekday, and now what I am doing is I am assigning day is equal to something like Friday. Okay, and then I am printing printf percentile d, comma Friday. Oh, sorry, not Friday, but we have assigned it to day, so we can simply write day. And now what it will print, we will see. So if you see here, it is printing 14. Okay, in second line it is printing 14. Why? Because the Friday value is 14. So in this way we can use this variable enum in this way also. Okay, and if you don't assign any value, by default it starts from 0. Okay. But one more thing we have. Now, if I'm using one more variable called enum, okay, and if we are using same variable or same enumerator, then it will not work. Now, I'm taking something like enum month. I'm just taking. Okay, we will just write week 3, and then I'm assigning here Monday, comma some day 2. Now, this will not work perfectly. Why? Because it will show us already Monday is declared with another enum. So this will not work. Still, we will just check this out. Now, if you see this here, Monday, previous definition of Monday was here. So we can't redeclare the same enumerator. If you are using any number of enums, you can use, but redeclaration is not. We cannot do redeclarations here. So you have to use a unique name or unique enumerators in all your enums. Then one more thing we have to, or anything we are left with enums are, okay. Now we will say something like why we are using this enum. In place of enum, now this was our program for enum, right? So what I'll do is I'll write one more program and we will simply use macros in place of this. Okay, that is nothing but hash define, right? So we will write edit macro.c and then I am declaring some macro hash define Monday as 1, Tuesday as 2. Okay, and then I can write my main program. Printf percentile d. Okay, this is our simple program which will return a same output like your enum. So here we have errors. Oh, sorry. In hash defines we are not supposed to use semicolon, and I think I have used a semicolon there. Sorry. Now, if you see we are getting same output like previous one, enum has only. So why to go for enum when you have this macro, or why to go for macro when you have this enum? So basically, why we are using, we have some advantages of enum over macros. Okay, what is that is, now enum follows scope rules. Already we discussed what is scope. Scope is nothing but whatever is there in your opening and closing braces. If you are writing something like a function scope is in particular that function only. If you say main function close starts from your opening brace to closing brace. And if at all, if you are writing in main function, if you are writing some inside your I'll just show you. In main function, if you are writing something and declaring here something like if, and then we are writing one scope, then the scope of here, if we are writing one variable called int I, at that time the scope of this int I is nothing but this particular opening and closing brace. So this is your block scope. This is called block scope. And if you are seeing this opening and closing brace for any function, that you call it as function scope. Okay, so enum does follow the scope rule. Okay, if whatever function you are writing enum for, at that time only enum will be utilized. Rest of the functions won't be able to recognize that particular thing, if at all, if it is not declared globally. Okay, and one more thing we have is here we need to declare everything, like hash define Monday, 1, Tuesday, 2. If we are writing 7, then we will have to define these numbers. But there, by default, it will be assigned automatically. So there are some instances where we want to assign the numbers automatically. At that time, it's better to go with enum rather than macros. Okay, but main thing is scope rules, because when you say hash define will be processed at your processor level itself, pre-processing. When you, before compiling, we will have a pre-processing step. At that time only this will be executed. But when you say enum, it will be then done at compilation phase. Okay, so that's why we have one advantage of this over your enum. I hope this enum is clear with you. So we can go with next topic. Okay, so just now we have discussed something like your enum, static, local, scope and everything, right? So now what I'll do is I'll just to show you what is the memory layout of a program, such that whatever we go with now, so it will be easily understood by you. Okay, so here what we have is, when you are executing your program, when you get this a dot out, what will be the format of this a dot out? We will have to see what is there in this a dot out, and what have where exactly we are storing this local variables, global variables and everything. So here you will have one. Already I think once we have discussed, but now when you know what is scope is, what is this data and all, it will be easy for you to understand. Okay, before that, again one more thing, I do better to go with this one's variables only. These are also small topics. Okay, so here you have something like just now, as we discussed some variables, we have local variables, static variables and global variables. Okay. Now what are these variables? Basically variables, already you know what are variables. We are allocating some amount of memory to them, but depending on what is the scope of this, we are dividing it into local, static and global. I think you remember local, just now we have discussed. Whatever is there in that particular function defines your local variable. If you are writing something like in main function, or you are writing in some add function, if you are writing b is equal to c equal to a plus b, return c, that's it. C is there only for that particular add function. Rest of it will be destroyed once the control goes to main function. Okay. So that is your local variable. Now, do we have some rules with this? We have some points we have to see, that these local variables will be allocated in static memory. Where the static memory is, I'll say you. But, no, sorry, not static memory, but stack. Okay. In a dot out, we will have some memory layout. There, this local variables will be assigned in stack memory. Okay, I'll show you the memory layout. And thereafter we have something like scope. Scope, as I said you, opening and closing braces, the local will be alive only in that particular block. Thereafter, if we are not mentioning anything with local variables, the storage class of your local variable is auto storage. We have seen something like auto storage, then we have register storage, we have something like other than that we have seen one more storage class also. Okay, we have seen auto, registers and static storage class. All these things we have seen, but still I'll just repeat it once again. the auto storage class, it will be by default whatever variables you write, it will be under auto storage class only. So this will also have auto storage class. Now, one more important, very important thing along with this local variables are, you are not supposed to return the address. We can return the value of the local variables we are returning, but we should never return an address of your local variable. What will happen? We will see then. What will happen if we are assigning a address of local variable? Okay. We will write a small program for that. Local.c. Now, I am trying to return the address of a local variable. So here if you see, so we will have to take one function. So I am using a function pointer. Okay. So we will just write one function with this pointer. This is a pointer function. I am not passing anything inside this. So when you write in pointer function, this specifies that you are going to return an address. Okay, like we are saying integer function, if we write int pointer p, p is a pointer that is returning an integer. Here function is a this is a function which we are returning an address to a now. So here what I am trying to do is, I am trying to fetch this. So as we are going to return an address, we are simply writing int pointer p. So here I'll just assign this p with this function, or you can do it later also, your wish. So I am assigning here like function. Okay. So what we have done here is simply we are assigning the address of this to your pointer function and then pointer variable, sorry, and then I am trying to print whatever is returned by this. So function returns an address. So we will have to write a function for this. I'll write the function first and then we will write int pointer function. So here I am taking a local variable now. So local variable like int I is equal to some 4, and then rather than sending this return I, what I am trying to do is I am trying to send the address. And here also my pointer p should have already we have assigned that it will be containing address. So here, so what I have to do is simply first, okay, I just do like return I. Okay. Oh, sorry, return I will give you value. So I'll write address of I. Now my function is returning an address. Okay, and here I am going to have this address in pointer p. So I am going to print this pointer p. So here what I'll do is print %d \n, comma pointer p. And then return 0. Okay, so I think you are clear what we are trying to do here. Okay, this is the scope of this I is. This I is a local variable because this is opening and closing braces. So this is a local variable and this will be assigned memory in stack. Okay, so once you leave this function, this variable will be destroyed. But what we are trying to do is, we are trying to get the address of a variable which is already destroyed once you pass the control to main function. Okay. So what error it will show you, we will see. Does it show some error to us or not? That also we will have to what will happen. Now, if we see here we have got some warnings that print, did you mean print okay in place of I have, sorry, printed, right. Any other things we have missed? No, I don't think so. Okay, so we have got one simple warning, and that is function returns address of a local variable. This is the warning we are getting. Okay. Function passes the control to main function, this will be destroyed. So it is going to return us an address that does not contain the I value. Okay, dot slash a dot out. Now if we see this, we are getting segmentation fault. Already we discussed that segmentation fault is nothing but we are trying to fetch a memory. We are trying to access a memory which is not in our range. It's not there. Okay. So already we are using, already that element is destroyed, but we are trying to access it. That's why we are getting this segmentation fault. Okay. And this will call, as we are using one pointer for that, we are calling it as dangling pointer. Okay. So dangling pointers are once you delete that variable and still if you are trying to access the address of that, you call using that pointer. You are trying to fetch the address using the pointer, but that variable or that address is already destroyed. That you call it as dangling pointer, because that pointer is pointing to a variable which is not present. Okay, so that thing you call it as dangling pointer. I hope this is clear. Next we are seeing static variable. I think if you remember, we have already done one program for static variable. Static variable basically stores the previous value. Static variable stores the previous value. Just a second. Kaushik, 5 minutes, Kaushik.
Sure.
Okay, so we were getting the data like, so basic. You're there. Hi Kashik there. Okay, so we are not supposed to return the address of your local variable. If you return the address, okay, already we discussed, I think. Okay, static variable we were discussing. So static variable, previously we have seen the example of static variable where we say that static variables restore stores the previous value whatever have been used. You want me to write once again or no need? Okay, we will write one program for static also. So we will use same program. Okay, otherwise we will write one more program. Static.c is static variable. So we are writing one function int number. We are not passing anything here again. And we are writing our main function. So I'm calling this function toward 3 times I equal to 0. So I'll write something like for loop where I equal to 0, I less than 5, I plus plus. What I'm trying to do is I'm trying to call this number function. Okay, now this is my simple function where I am calling my number function 5 times. Okay, so as we discussed, if we are saying, okay, first we'll do it with your normal d integer, 1 digit is there, so we are taking into digit, and then I am initializing it with 0. We are printing your number, okay, 5 times. So here what I'll do is printf %d \n comma digit. Okay, this is our function. So we are calling number function using for loop, and then here what we are doing, we are taking one variable and we are printing that number. Okay, so this should print 5 zeros. Okay, so we will write this gcc static.c. Now if we see, we are getting all zeros, right? Why? Because as we discussed, this is a local variables. Once we shift the control to your main function, this digit variable will be destroyed, and this variable is stored in stack memory. Okay, so I don't want this digit to be destroyed. I want this digit to store its previous value. For that, what we will do is we will take one keyword called static. Okay, static. Now, what does this static do is it will retain its previous value. It is one of the storage classes, and we have it preserves the values. Okay, now if we just save and execute it once again after writing the static keyword, now if you see the output of, no, something is wrong. It has to be static into digit 0. I've not recompiled it. Something is wrong here. should not display this. We did something wrong. Need to find it out. Static int. We have not done any mistake, I guess. We are calling this function just. There is no problem with this function. And why it is not. I don't see any why this is not executing. Just to try to find it out. And because the previous day we executed, it worked properly. Today it is not executing. Static. Not do this. Just a second, I am trying to find out what is the error we are doing here. We are calling this function. Just a second, just for see. Once we declare this, I just once I just day before yesterday worked and nothing is working out. Static is not at all working anywhere. Static integrity. What is there in this? This is perfect actually. Why it is not working? I'll just create one new file and then I'll try to write it down once, because nothing is wrong with this program, or else I will have to restart my system once. Here, this is the same program. We have used here static int, and we will just check this again. C. Here it is working perfectly. That means we have done something here. I'll try to remove this. Here it is executing properly. First value of C is 6 and then second value of C is 12. I'll try to remove this for loop and I'll try to get this number. But this should not make any difference, but still I'll try to execute this once. No, there is some problem. It must retain the previous value, but it is not retaining the value. There is no problem with the pointer 3.c. We'll try to return the value. Rather than printing, we'll try to print it here. Here also I am taking one variable called int_digit. We will take only digit. I am just trying to find out what might be the error here. Because according to me, we are writing everything properly, so static should not work this way, but just for confirmation that what exactly we are doing wrong, I'm trying out different ways. So here we are simply calling this digit number printf percentile the digit. Here we need to return it. So I am writing return digit. Oh, okay. I understood what is the problem. Sorry. Shit. Okay. Sorry. It is my logic mistake actually. We are writing when for loop or everything. This is perfectly fine. There is nothing wrong with it. The only thing wrong is we are not at all incrementing the value. So when we are not incrementing the value is 0 and it is retaining that 0 value. But now if we increment the value, then it should increment it. Okay, so that's my logic problem and not this anything else. Now, if we see, we have done mistake of not incrementing it. That's why it's retaining its previous value. This is static.c. Now, if we see, we are able to see the previous value. Now, even though here this variable is a local variable for this particular function, digit is the local variable, but as we are writing this, it with static, it is retaining its previous value. Okay, so that means what? It is not destroying its variable. That variable is there even after we return the control to your main function. So that means what? It is like when we are the scope. Now when we talk about scope, even though it is a local variable related to this particular function, but the scope of this variable will be throughout the program. Why? Because it is retaining its previous value, or it's preserving the value. That means the scope of this particular static is whole program, wherever or whenever you call it. Once the control comes, it is not destroying its variable. Okay, so it will retain till the program runs. And by default, when you are writing your program and you are writing a global variable, now we will see what is that global variable. But when we are calling that global variable from other files, like we have two different files. One is static.c and the other one is something like volatile.c. So if we are calling this variable from that variable, it will work properly. By default, it is that variables are accessible to other files also. But when you declare this as this particular thing as static int, now this static int digit 0 is accessible to other C files also. Sorry, not static, but if you write only int digit, if you don't write static and int digit equal to 0, then this variable digit is accessible to other files. But when you write it like static, this is accessible only by this particular file. When we are writing different function, big project, at that time we may have different C files. So at that time we may need to access different variables from different files. But if we don't want that to happen, and this has to be only, this variable is accessible, it has to be accessible only by this particular file, you can use this static keyword. Okay, then if at all, if you are writing static and if you are not initializing it to 0, then what happens? Now we are incrementing the value, okay, but we are not initializing any value to your digit. Then will this work properly, or what will be the output? Now if you see, that means what? By default, your static variable is initialized to 0. When you don't write this static and if you simply write this int digit, okay, then what will be the value? This is local variable now. This is no more a static variable. This is a local variable and we are simply printing it, right? So will it give us 0? I don't think so. Now if you see, we are getting some different values. Okay, so it is not giving us 0, which means that by default, if you are not initializing a variable to static, it is defined, it's the responsibility of your compiler to initialize it with 0. Okay, and now where your static variables are stored. There are two memory locations in your memory map, which we will see. There two sections will be there. One is your BSS and one is your data section. If at all, if your static variable are initialized, then that will be stored in your data section. And if it is uninitialized static variable, then it will be stored in BSS. Okay, we will see that. But for now, you just remember that the memory locations for this static int is not stack memory. It is stored in either in data section or BSS. This is interview question, that where the static variables are stored. So static variables are stored either in data section or BSS section. Okay. Then the other thing related to this, one more point. That's it. I think we have only these many things related to your static. Okay. The last one is your global variable. When you are writing anything outside your main function, you are using some Today, whatever we are just discussing or writing, all are related to interview questions only, but these are small topics which are very much important because these are the general topics which are neglected but asked in interview. Because generally after practicing program, we will say that, oh, okay, we know all the topics, but main topics might be known. These are small topics which are now. If we print it, we'll get the normal value. Now the value of your A is 1. If you see what is the scope of this variable, then we can simply say that here we have initialized it to 0. We will not initialize it to anything and we will see what it is printing. But after that, what I want to do is, I want to just print this 5 times and first int I equal to 0, I less than 5, I plus plus, printf, and thereafter I am just incrementing it after printing, so I am writing number plus. Okay. So what we are trying to do is we are simply trying to increment this particular number and I am not initializing it to 0. That means what the global variables are initialized to if we are not initializing it while declaring the variable. That means what? By default, your global variables are initialized to 0. Now, with this logic, what we can say that is the global variables are stored in one data section called in memory layout, one section called data section. So your global variables, same thing. Initialized global variables are stored in data section and uninitialized global variables are stored in BSS. Global variables by default are external, which means what? The other files are able to access those variables. Okay. I hope the scope. If we are saying scope of this local variable, these variables will not die till your program exits. Okay. That's it. I think we are clear with this global variable, static variable, as well as local variables. Right? Now I'll say you the memory layout such that it will be easy for you to understand the next section. Okay. Now, so when you are executing a program, you are creating one file, right? Executable file. That is so when we are running that, it will create one memory location. So how it will be is, I'll share one screen once and I'll show you. Sorry. Now, if you see this here, the memory layout will be like, once you are running your program, a block will be created in your memory location. Okay, so here the section already we have discussed it, but now you know what is static variable, what are all these variables. That's why I am saying it again. So this is the memory layout of your section. Okay, so here you will have some sections. This is your start section. This is your keep section. Then you have this uninitialized data section, initialized data section, as well as your text section. So now here this is the part where all the commands will be stored. Whatever program you are writing, the end thing, whatever you are getting is stored here. Process whatever commands has to be executed after writing your a dot out, all the things will be stored in this particular section called text section. Okay, and this memory layout will have the lowest address. That means if you are starting with something like 000, here the lowest address will be at this particular 00 location, your text will be there. Okay, and this is the highest section. How much memory it is allocating, that depends again on your processor. Okay, so this will have high address, and I am assuming it's something like FF just per our understanding. Okay, so this text section will have 00, and you're able to see the screen, right? Okay, so text section will have 00, and the highest address is your FF. Now, the next section here, this particular thing is your data section. Here, all the initialized data will be stored. That is, global variables as well as static variables will be stored at this particular section called initialized, or you can call it as data segment. DS, data segment is there, where all the data, all the initialized data related to not local variables but global variables or static variables will be stored. The same global variables or static variables which are uninitialized will be stored in this particular section of memory called BSS. This BSS is called block started by symbol, because we are not initializing any value to it. So we have only symbol, like int A is there, that's it. We are not assigning any value, we are not initializing it, so it's just a symbol. So here we call this particular section as block started by symbol, and all the uninitialized data will be stored in this section, which is global as well as static. Next, this is your what you call it as, here you will have one more thing we will discuss later. This is command line arguments. Okay, command line arguments will be whatever arguments we pass while executing your program. Like we are writing /a.out. Along with this, if we are passing some arguments here, then that arguments will be stored at this particular location. Okay, this we will see later. Here we will have something like arg C and argument C and argument B, that will be stored. All these particular variables which are passed in command line while executing the program will be stored in this particular section. Now, here this is the section where your local variables will be assigned. Here you call it as stack memory. This is your stack memory, and this is your stack memory, and this is your heap memory. Okay, now what is this heap memory? We will see after some time. We will see now only, but we will see after some time. You will be able to understand. Here the stack memory grows in this particular address way. That means memories, it will grow from high to low, the address locations after assigning to variables. Now if you are saying A will have some address like int I have some address like 80, then the next address will be decrementing. A will have the address location of 76. Like that, stack will grow downwards and heap will grow upwards. Okay, heap memory is the memory allocated while running. Okay, when you say stack, when you are compiling the program, you are allocating some memory in here. Okay, so while run time, if you are allocating some amount of memory, that goes under heap memory. Okay, whenever you are calling any functions and that function have local variables, that memory will be assigned in this stack. That memory will be allocated in this stack function. Okay, a stack frame, you call it as whenever a function is called and some elements are created, that you call it as stack frame. Okay, So every function, if you are calling some function like addition, subtraction, multiplication, all the functions will have one stack frame, and in that stack frame the local variables will be allocated. And other than that, as I said you, this is something like it is growing downwards. So this is like last in, first out. So whatever comes last will go first. The stack will have this feature, last in, first out. And we will have some register called stack pointer. Okay, that will be always pointing to the top of the stack. Always it will be pointing to top of the stack, because last in, first out. That means first element will be always pointed by the stack. Okay, when you coming to heap memory is allocated when you are writing in, when you are using the program. Okay, it will be allocated at runtime. And here you will have something like functions will be there. Which functions will be, like I said you, functions, when you are using your functions, that functions will be allocated in this stack. But some functions are there called malloc and calloc, free or realloc. All these functions are used to allocate the memory in this heap section. Okay. We will see that we have not seen that malloc, calloc, freealloc, free, and one more is realloc, but we will see now. And the last point here is, this is exactly opposite to this. It will be like it is growing downwards and it is growing upwards. And other than this, we have this we discussed this BSS. This is also an interview question, that what is the memory layout of C and what will be there in this. So basically you need to explain that text, what is there in data section, what will be allocated in BSS, stack, and heap, and R. Okay. I hope this is also clear. And I hope this text is also clear, right? So we can go to next topic then. Okay, one more thing we can do is, we can find out what is the memory layout. Okay, so we will see, we will write 2-3 small programs, and we will see what is the layout of your memory program, such that it will be very easy for you to understand. We will write some small programs now, just a 2 to 3 line program, and we will see. Because we need to find out what is there in this, or how we are going to see this. I will share this screen. Okay, so we are simply writing some layout program. I will write. We will just how it is allocated. Now, first we will not write anything in this, and we will simply write a return function and see what are there and what is the hash include. I think after some time this will just disconnect. I'll just join again if it is disconnected. Next I'm writing and I'm not writing anything inside this, just I'm writing return 0. And we will just see what happens and what is the memory layout of this. Now, here we will see the command will be, we have to change some command because we want to find out what is the memory layout. So memory layout is our first, just to give our C file name only, memory layout.c, and after that we will write -o and we will name it as memory layout only. It should produce, just a second, I have missed something, I guess. Oh, sorry. One more thing we need to do is, okay, so now we have created, using -o, we have created one file. Okay, just to see this file, what is that file is your memory layout. Just to see, one more file is memory layout. Can you see this file, memory layout, in green color? Okay, this is your object file because we have this is also, yes. Now we will see what is there in this file, or what is the size of this file. This is same file called a.out. Okay, a.out file and this memory layout file are same. If you want to see, just we have given name to your output file. By default, the output file name we are getting is a.out. Okay, once we are compiling the program gcc global.c or gcc memory layout.c, we are getting directly one output file called a.out. But I want, what is happening for all this, when you are writing local.c, pointer.c, this file is just overwriting the output file. Okay, first when we have written local.c a.out, but second when we write pointer.c, this file will be deleted and it will be overwritten by new file. Okay, but I don't want to do that. What I am doing is, when you write this -o and if you give a name, then what will happen is the output file will be created with that particular name. We can see that /memory layout. In place of /a.out, we are writing memory layout. We have written some mistake. No, this should execute properly. Okay. I think I have missed one more command. I'll just find it out, but right now we will just find what is the size of this. So size space memory layout, or you can say a.out also, we will see memory layout. If you see here, size of this your memory layout is, text is 1418. The final binary file, you can say, or assembly file, whatever is there, the final file of your executable will have this many text things, and then your data is 544, BSS is 8. This is your DEC. What are the what decimal number, hexadecimal, file name is memory layout. Okay, this is your normal size of your memory layout without writing anything in your program. Now if you write something in your program, I'll just write something in your program now and we will see. Now first we will write one local variable and then see. I am writing one local variable inside this, and I'll say you that also, that why it is not creating that output file. I'll just see that also. Int I equal to 9. Okay, so simply we have just initialized it, and now we are having only one particular size. If you see the size now, here again the size is same only. Okay, even though we are writing only a local variable, we are declaring it, that's it. So it is not giving us anything now. Now we will see the change here when we use the keyword static. So let's see, here we are writing it like static int I. Why? Because the local variables are initialized in stack, but we are not seeing anything in stack memory here right now. So now if you see here the data section, this is initialized data section. Okay, initialized data section was there, that's why we are getting data as 548. Here it was 544, but if you see here is allocated in static memory, it is there, that's why it is allocated in data memory, and here you have as integer is of 4 bytes, that's why your data became 544 to 548. Okay, so this is your static variable. So static variable, even though you are declaring it, it is stored in your data segment. Why? Because it was initialized. Now we will not initialize this, and we will see where it is showing now. It might be somewhat boring for you, but this is important for your interview questions. That's why I'm executing and I'm showing you. Why? Because mostly these are very small things, and you'll be feeling like what is the need to execute all these things, and that's why I am executing it. Now if you see here, previously I was initialized, and that's why the data was 548, and now again data becomes 544, and the data will be there in your BSS section. Okay, why? Because that is static memory. So by default it is 8, so in this 8 only it is allocated some memory for static. Okay, now we will see one global variable also, and then we will conclude this. We will just take this variable and we will make it your global variable, and that is uninitialized global variable. Here if you see, here this is not changed, but that memory will be allocated in BSS. Okay, if you want to see BSS is incrementing or not, just to take one more variable and see static int I, j, k. So now this has to be in your BSS section. See here, BSS has incremented to 16. The base size of BSS was 8, that's why whatever we are using it was there in this BSS. But when we are using more elements, then this is incrementing. As we have used 2 more elements, that's why 4 bytes, 8 bytes are added to your BSS section. Okay, I think this is also clear with this. So you can see that the initialized global and static variables are declared in this data section, and the uninitialized uninitialized global as well as static variables are stored in this BSS section. Okay. So we can go for next thing now. So here we have one more qualifier. We have some qualifiers in C. So some qualifiers are something like what a qualifier is, it just gives some extra power to your variables. Okay, so like that we have some qualifiers which we will be seeing. We will be seeing 2 qualifiers. Actually we have 4 qualifiers depending on what is the C we are using, like C89, C99, C11. So we will see 2 qualifiers here. The 4 qualifiers we have is constant, volatile, restrict and atomic. These are the 4 qualifiers we have. Okay, but we will be seeing only 2 qualifiers. One is constant and the other is your volatile, because we are seeing C89. That's why we will see these 2 for now qualifiers, constant and volatile. Again, these 2 are very important for your interview questions. Okay, now what is this constant qualifier is? It just makes an object a constant. It just says that this is non-modifiable. So like we say, if it is a constant, yes, it's a constant. You can say alphabets, numbers, anything. You can't change the value of 1, right? 1 is 1 only. So it's just an example, that's it. So here this qualifier declares that if that variable is assigned with a qualifier, it is just a read-only variable. It just assumes that it's a read-only variable and it cannot be modified. Okay. So what is the syntax for this? So we will see syntax for this. One more thing I have to remember, I have to say you is why this didn't execute that memory layout. We'll try once again. What is the okay? It might not be executing because we are not printing anything. Okay, so we will write this command once again in this constant while printing, and then we will see whether this is executing, this command is not executing or not, or I am doing any mistake. Okay, so this thing GCC-0 memory layout, as we are not printing anything, it's not displaying as per my knowledge, but we will see it again. So what is the syntax? So we will go with this first gedit constant dot feed. So what will be the data type for this is syntax for this is, so whatever data type you write, simply you have to write this const, const, and again you write something int I is equal to 0. So this is your syntax for your constant. Whatever you write, your data type, just you are qualifying that to one keyword called constant, which makes it non-modifiable. Okay. Now we will write one simple program and see what will happen when you are trying to modify the data. Okay. So we will write one program. We will simply check it out what happens. We are declaring one variable and then we are trying to print this. Printf will work perfectly. There is no problem with this. Just we are printing for I. Now I will try to change the data to I equal to 9. And then again I will try to print. What will happen we will see now. Now we are trying to print something, but if we don't get any error, that command will work properly. So first we will just see this. It should give an error or warning. We will see what error or warning it is giving. See, here the error is assignment of read-only variable I. Already we have initialized this variable and again we are trying to modify this variable I is equal to 9. That's why we are getting the error. Okay. So now what, I hope this is clear for you, but now what is the use of this? Why we are supposed to use this? So basically, why we are using this is when we are not able to change it, there is no meaning of passing it. There is no meaning of using it, right? But there are some instances where we are not supposed to change the value, or we want to be sure that whatever we are passing is correct value. At that time we are supposed to use, and there are something like mostly we will go with parameter passing in functions. When you are using functions and you are using call by value, at that time, not call by reference but call by value, we are using this constant variable. Okay, and there you have some. Okay, we will see that with some example also. Okay, now already we have seen that when you are trying to modify it, it is giving us error, right? But we want to modify this value. Then can we do this? Can we do it with directly? Obviously we are not able to. We are not able to change the value of this, already we have seen. Then how to do this? So basically, wherever you don't want to modify the value, mostly we are going with that only. Okay, so mostly we will go with pointers here. Either call by reference you use, call by value use. If you are using it call by value, at that time you are not trying to change the value. At that time you can use it by call by value, or otherwise if you are storing some address and you don't want to change that particular address, at that time you can go it by call by reference. Okay, so when you are using some pointer functions along with this, at that time we can go with this constant value. Okay, that means what if I am taking a variable and I am assigning a particular address, then that particular address we will not be able to change that particular address. Like I have something like constant pointer int pointer p, and then I am assigning it the address p is equal to address of I. At that time, once you do this, then you will not be able to change the address of this particular p variable. Why? Because now it is constantly, you have already declared that this is pointing to an integer constant. So you will not be able to change the address of this pointer again. Okay. So when we are going to use this is when you are using, as I said, you function. We are not writing right now. I'll show you something, but when you are, I think right now there is not correct time to show you, but what is the application of this we will be seeing when you are writing your functions in your RTOS as well as your device drivers. I think we will see it better there, otherwise we will see only errors here. So this topic we will see it later. I think it's better, because simply whatever we are doing, we will just print it and we will find one error here. So we will, and one more thing, what we were doing right now is we will just print it and we will see whether that particular output file is executing or not. So here I'll just comment all these things. I'll be showing you the constant qualifier use, but as of now we will just pause it. GCC C. We will restrict it to this many programs only, but practical application we will be seeing while while writing other programs or while using it. Const. Now, gcc const.c -o const is the name I want to give to my output file. Now, if you see, an output file will be created, and then if I see this dot slash okay, see here dot const value is 0, my output is created. Okay, now this file a dot like a dot out, I was right that we don't have any printf, that's why we were not executing this memory layout. But now as we have printf here, when you write simply dot slash a dot in place of a dot out, if you give already we have created one more output file called const, and dot slash const gives you the output. Okay. Here this constant actually is somewhat complicated. We will see this, but we need to definitely know this because this is so very much important. We will see. One more qualifier we have, and that is also we will give a short introduction to this also. This is also one of the very important interview questions, but the use practical application of it we will see in big programs. Okay. So volatile, where we are using and what is this qualifier used for is when you don't want your compiler to optimize a particular variable, at that time we go with this volatile qualifier. How? We will see that now. Either it will be stored in cache memory or register memory, but we can't say exactly where it will be stored. But this variable has to be, it can be stack or anywhere it can be, but it will make sure that this is fetched every time you are executing the program. Sometimes our program is not doing anything on a variable, okay, but it can be changed from externally. If you are able to change that externally, at that time there is a chance that there is no logic written in your program for that particular variable. Okay, so compiler will simply optimize and just assign a particular value to it, and it will not check that value again and again whether it changed or not. So to make sure that that variable can be changed externally, you are using a qualifier called volatile. Generally we use it with microcontroller. Here also we can use, but in terms of embedded systems I am saying, in embedded we can be using it with GPIOs, whether that switch value changed from 1 to 0 or 0 to 1. We can use it for interrupts, or we can use it for flags to find out flags whether the value of that flag has changed or not. So we will be declaring it. So we will see some basic of it like we have seen for const. So declaration for this will be same, volatile int sum I equal to 0, or even this is also okay, int volatile, both are same, I equal to 0. Okay, both are same, either you can write volatile before or after, this will make no change. So here how to see the practical application of this, because it is changing externally. I think we need to do it using that only. Practical application I will not be able to show you. I am just thinking whether I can give you a practical application. So I don't, without microcontroller I don't have any example, because simply giving it externally okay, we will see this with your microcontroller only. Just to, if at all if I forget, just to let me know that we have not used two things, one is const and one is volatile, but as of now you will have to say that you should know the basic of this. Okay, why? Because we need to use some microcontroller to see this application. The next topic we will see is one variable called, or one keyword called type define. Okay, now what is this type define? Type define is nothing but if you want to name already existing data type, whatever you want, then you use this type define. Okay, so what does this mean? If you are using something like different bit, like now my integer here is of 2 bytes, but in another machine my integer is of 4 bytes, depending on what is the bit, 32-bit system, 64-bit system, or how many bit system you have, 8-bit system, 16-bit system, depending on that your integer, your data type's range will change. So there what we do is, if you want to make a program portable, like I am writing a program for your 8-bit system, but I am trying to run it on 16-bit or 32-bit system, at that time all the equations will change. So to make sure that everything is running accordingly, we have to use something called type define. Okay, so what is this system? I think this part, this also we will not be able to see some practical application, but I'll show you how to write and what is the syntax for it. So the syntax for this will be simply type define, and now I am saying that I want to change the name of the integer or unsigned integer, signed integer, anything, or we can simply say char, better char, and I want to name it something like I don't want to use the keyword called char, char A, char B, I don't want to use. So I want to change the name of something like alphabet, or I want to name this as variable. Okay, so when you are writing something like char A, in place of this char A is equal to simply 0 or A, B, C, anything you write, in place of this you can simply write variable is equal to variable A equal to 0. So does this make any difference? No, but it makes it readable, that you know that in place of char I am able to use this particular name. So basically we are trying to change the name of the existing. We are not defining any new data type, but we are modifying the existing, modifying the name of the existing data type. That's it. We are not changing anything, but we are simply. Now, one simple example we can see is, this is obviously, now generally what we do is, when you are writing unsigned integer, okay, how you have to write is unsigned space int. Okay, you will be writing it in this way, but sometimes I don't want this space. Okay, so what I'll do is I'll simply write like unsigned int without giving any space. That means now in place of this you can simply write this. So there is no need of giving space, or there is no need of giving any uppercase, lowercase. Simply writing unsigned int will solve your problem. Okay, so you can then write unsigned int I equal to 0 in place of this. No need of giving space, or no need of seeing uppercase, lowercase, anything. Mainly we use it for portability. Okay, how to say that is, now suppose what I am saying is type define. Here what I'll do, I'll say that my integer, wherever by here, just to define it like integer is of int underscore 32. Okay, that means what? My integer is of 32 bit, or you can say that this is of 4 bytes. At that time it makes it very readable, that my integer, when you are writing your program, then you will be able to simply say that okay, here the integer is of 32 bit. Integer underscore 32, I can say I equal to 9. So this particular thing will show me that okay, this variable is of 4 byte. I need not again find out that what is the size of integer on this particular machine. I hope this is also clear for you. So this makes it clear as well as portable. Now, again we have one more thing called type define can be written outside. Okay, then here we are using this type define as well as we are using again we are using macro also hash define. Either you can use type define or hash define. Then what is the use? Why we have to use type define or your hash define? So as we discussed, the hash define is preprocessing. But type define again has scope rules. It is used only where it is defined. That is again one use of your type define over hash define, or you can say macros. One more simple program I think again this particular application we will be seeing in your while writing your device drivers as well as your RTOS. But if you want to just see this application, we can just write one small program. Here I am writing that. Type define. Enter your variable. So now in place of variable in a comma b, we can simply write variable a comma b. A equal to 1, b equal to 2, return 0. So here whether it will throw errors or not, I'm seeing that's it. We are not printing anything. If we want to print, we can print particular thing like %d backslash n comma a comma b. That's it. Now, if you are defining your type define in your function, then as I said, the scope of this will be inside your function only. One, two. Okay. Now we will try to just edit it and call this particular function in your main function. We have not declared it externally. We have defined it just to show the scope of this type define. We are writing it int function, and I am trying to fetch this particular thing variable I equal to 0. Printf %d backslash n comma I. This should throw us error because variable is not any data type inside this function. See, error. There is no type name called variable because this is your scope rule. When you declare a macro, it is for whole program, hash define. But when you declare it for only particular functions, then you go with this scope rule. It has this advantages over your hash define. Okay. If you write it externally, then it will be for whole program. Now this should not give you any error. Oh, sorry. What was the program name? I forgot. I forgot program name. The last program we have written was here type define. So if you see, it is executing perfectly. Previously, when it was in one particular scope, it was not working properly. Now we have something like one more important question you have. I will ask you to do that. Just to toggle the bits. We have done toggling program in your microcontroller, right? So same way, toggle a bit using this bit operators. Okay, you have some operators in C, right? Or, and, not, addition, subtraction, anything. So basically try to toggle a bit using, it can be 8-bit, in particular 8-bit, 5th bit you suppose. So try to write a program to toggle a bit. Set it, clear it and toggle it. Write a program for that using only one operator. You try to do that. Then already we have seen void pointers, the topics which I have left. I am seeing that once you get the basic idea, we can just go with some other things. That's why. What again I have left is update your dynamic memory allocation, which is CLO, malloc, CLO, and that one. So we have some. Shall we see some examples for yours? Already void pointer we have discussed, right? Void pointer is a pointer which can be used for any data type. We have seen that again, but if you want, I'll write a small program for that again. Then we will see null pointers. We have not seen null pointers, void pointers, and then dangling pointers. Okay, these 3 pointers are there: void pointers, null pointers, wild pointers, as well as dangling pointers. We will see example for this. So we will write some program for this now. Just a second. Is it okay if we continue for just for some more time, so that I can finish this small topic? Kaushik, shall we continue or shall we stop? Okay. So again we will start this with void pointer and then we will see one by one. So void dot c. Better to write void underscore pointer dot c. Okay. So as we discussed, this is a generic pointer, we can say. You can use it to point any type of data type. Okay. Already we have seen this, but just for once again, as we are going to see different type of pointers, we will just execute one small program for this. So the declaration would be void and then pointer name, pointer anything like void p. That's it. This is our pointer name. So this is simply declaration, and again the thing is here the size of this will be depending on what you are going to allocate to it. Okay. But by default, when you say the size of it is 1 byte. Okay. Next, now we will write one small program to see this. So here we have this as, or if we want to see what is the pointer size, we will see then hash include stdio.set. Better to see if we allocate the generic pointer and then if we try to see what will be the size if you allocate it or if you use it for different type of variables, we will see how it will work. Okay, so first of all we will simply write this void pointer p, and then here we will write printf size of my void pointer is equal to %d \n comma, here we will give size of operator or size of keyword. Size of is used to find whatever size of variables you have. It can be integer or anything. Directly you can even write size of int. It will give you 4 bytes. So here I want to find out what is the size of p, which is my pointer. So simply we will write this. So I want to find out what is the size of my void pointer. GCC void underscore pointer dot c. So here it is giving me 2 errors, and that is I have done some editing error, and that is here I have not given one parenthesis, and even to remove the warning I will write return 0. So here I have a warning that whether what is the size, format expected was your integer unsigned long integer, but we have written %d, but that's okay. Dot slash a dot out, and we can see that size of your void pointer is 8 bytes, that's why it has shown that it is long unsigned int, but we have written percentile d, which is for only short int, or we can say unsigned int. That's why we are getting this warning. So my size of void pointer is by default 8 bytes. Now if I want to assign it to some other variable, like I want to say that what is the size of your, I want to find out something like, we have seen that now I am writing this pointer and I am writing one variable like we did last time, int I equal to 10 I have written, and the address of this I want to pass it to your void pointer. So p is equal to address of I. Now my void pointer is pointing to an integer, so same thing I will have to say, but what I have to say is, now my void pointer is an integer pointer. So what we will do here, simply we will remove this and we will say that now this is pointing to an, now this will give us error. Last time we have seen that. Okay, we will get error. So what we need to do is pointer. Now here we need to give, this is an integer pointer, and here we have to give p. So in place of void we are writing int pointer. This is my pointer p value. Okay, so here we are simply saying that in place of void we are writing integer pointer. That's why we are getting this. So here the value we are writing. So here we will see now that, okay, we will see even size also. So void pointer value I is equal to 10. Now what we will do is we will try to use the same thing per character. So this should give us same. Now char some ch is equal to character is equal to a. Okay, and then after printing this, what I'll do is I'll just take this, Control C, and I'll copy it once again, and here I give the address. After giving this, I'm giving the address of this character variable to my void pointer, and then here I'll change it to char, and at the same time we will try to find out the size also. So printf size of your void pointer is equal to %d \n, comma, here we have to write size of pointer p. And same thing we will write here. Mostly this should give us 8 bytes only, but still I'm just checking it out. Otherwise we will have, mostly it is of 8 bytes only, but let's see. So here we got some error. Okay, again this is your typing error. So here what error I have done is I have not closed parenthesis. Here also I have not closed the parenthesis. That's it. So here my program name was void pointer.c. void underscore pointer. The warning format error is there again. And we have some error here, which is comma. Here also a comma. These are just a typo mistake. Warning error again. Semicolon. I hope there is no error now. This is fine, no problem. Why? Because it's showing 8 bytes. That's why we have written %d. Now if we see here, the void pointer values are changing. It is 10 and small a value is 97. That's why it is showing 97. But the size of the void pointer is 8 bytes only. Okay. So basically, this is the size of the, even though you are using void pointer, but the size will not change. Only when you, but you are able to use the same pointer for different data types, and that is the use of your void pointer, and this is generic pointer. That's why we call it as generic pointer. Okay, so already we have seen one example also, so we will go with some other thing now. So next we will see the other one. Next go for null pointer. Now what is a null pointer is, edit null underscore pointer dot c. Just a second. Hello, is there? Sorry, my daughter is actually 1.5 years, so she'll come in between, and that's why I'll just take small pauses. Okay, so we were writing for our null pointer. Now, what happens is, why you need a null pointer first of all? Null, what is a null pointer? Okay, so first we will see what is null pointer and then what is the use of it. What is null pointer is it points to nothing. Okay, so basically when you say null pointer doesn't point to anything or it points to nothing. Then if it doesn't point to anything, then why we need to use null pointer at first place? Now, if at all, if while using a pointer, if we by mistake, if we forget to assign a particular valid address to a pointer while declaring it, and without assigning an address, if you are trying to access that particular pointer, then it might be giving you some undefined behavior. Okay, or you cannot say what will be the behavior of that pointer. So at that time, your program may get segmentation fault or some other error, or your program may give you crash. Okay, for example, my point is that if you use a pointer variable, but if you don't assign it with a proper address, and if you try to use it at that time, you will get some behavior of it. Okay, at that time we will get some error. What is that error we will see, or how the system will respond to it. Hash include stdio.h. My point, I will say main. Now I am taking one variable which is my integer pointer p, and then directly I will simply try to fetch this value with some 1. I don't know, I am not assigning any address to my pointer, but I am trying to change the value of my pointer. Okay, then what it should do? Printf %d \n, comma, I am using the value pointer p. Now I have declared a pointer, I am using the pointer, but I have not assigned any address to it. I am not giving something like p is equal to address of I. I am trying to. Now what it should return? I don't know how the system will respond now. Return 0. So just to see what it will give us, gcc null underscore pointer dot c. So it is giving us an error, right? If at all it is giving us error, fine. Okay, just typo error, I guess. First we will see that what is typo error here. Main pointer p equal to 1, printf percentage \n. Here I have not given double quotes, that's why we got that error. Now dot slash a dot out. So here we got segmentation fault. As I said, we will get some error. We got segmentation fault because we are not using this pointer to we are not giving any address to this pointer, and we did not do it deliberately, but we forgot to do that. In this case, we can use this null pointer. Okay, so if you say that now here my pointer, I am declaring a pointer and I am saying this, it is null. Okay, at that time we can simply, now if we will run this program, hope this should not give us any error. So again we will try to modify this program. So first of all we are saying that this pointer is pointing to null. Okay, and this null is defined as 0 in your standard library stdio.h. So null is already defined here, so there is no problem. Now what I am trying to do is, here we will write one if condition, and we will write if my pointer p, or if you say if my pointer, because we are not assigning any address here, if my pointer is not equal to null, then what to do? Just assign this value. That means if at all, if it is if your pointer is not equal to null, then assign this value. Okay. If at all, if your pointer has not been assigned any value. Now we will see what will be the behavior of this. Okay, we got a pointer that it is an undeclared first used in this function. So sorry, this I have written here PTR, where it is P. Now if you see, we are not getting any errors, but it is not running your program. It is not because we have not printed anything. We have written one printf statement also. Okay. If it is equal to null, if it is not equal to null, we have written. If it is equal to null, we will see we will get any error or not. Okay. So what is the use of it is, if you see this, if it is not equal to, it is giving some, this particular logic is not working in your program, it is showing, right? So we have just observed that this printf is not working. So we are seeing that. So this helps us to find out that this pointer is not assigned to anywhere. So basically we use null pointer just to make sure that you should not get this segmentation error. Now if we run this, I hope this should also not give us any error. Segmentation fault again, as we have not given any address. So basically this makes sure that you don't have any address and you will get that particular point. It will come in picture. Okay. So this was about your null pointer. Coming to your void pointer. Wild pointer. Now what is this wild pointer? Okay, so what is this wild pointer are? If your pointers are uninitialized pointers, then you call it as wild pointers. Okay. If you are not initializing your pointers, they are called wild pointers. So they will be pointing to some some memory location. So if you are doing that, then we call it as same thing like your null pointers only, but we will get segmentation fault again. So here I'll write one small program, a same program actually. Okay, we will just write one small program, but we will make some changes to just understand this wild pointers in place of your null pointers. So I am writing one small program. Now int I is equal to some 1, and then we are taking one pointer, int pointer p, and then we are assigning it the address of your I. Okay. Once you assign this here, when you declare this is a void pointer. Okay. And when you assign the address, it is no more a while pointer. Okay. This is simple. I think this will be sufficient for your understanding. Just uninitialized pointer, you call it as void pointer. And here, which is your defined pointer, this is no more a while pointer. Enter percentile D. This will work normally. Pointer P. This will work at any other value. So it is giving us 1. We will see other things here now. With this, we will go with one more thing called dangling pointer. Already we have discussed, already we have seen dangling pointer, but one program we have written one dangling pointer. If at all, if we are pointing to one address location, which is no more in, we have written one address location in function. We have declared one local variable in function, and then we are trying to use that address in your main function. Already that memory is, or that variable is destroyed, and we are trying to access that. Then we call it as your dangling pointer. Okay, so this was your dangling pointer, void pointer, null pointer, and one more is your while pointer. Okay, I'll just give you one. I think I can't give you more example for this, but we will, while writing our programs in your data, RTOS and device drivers, we will come to have more operations on this. Okay, so now coming to next topic, 2 small topics we will do, and then we will conclude today's session. So now this is your dynamic memory allocation. Okay, now what is dynamic memory allocation? Is while running, now I don't know, suppose I am doing some registrations. Okay, I am taking some registration for some competition, and I don't know that how many people are going to attend that particular session. I need to enter the data of the people who are entering and registering. I don't know how many are there. So if we want to do this while running our program, now I have allocated 100. Okay, and if more people come at that time, if I want to do it in our normal C program using arrays, at that time what will happen? I will have to change the program that make the array 200. At that time I will be able to access. But that is not feasible, because I am writing a program and I am giving that application to you. So what we will do in such cases, we will use dynamic memory allocation. Dynamic memory allocation will allocate the memory at runtime. So if I give you that application, you can use it for 100, 200 or 300, depending on one more what functions we will be using, some functions for that. Okay, so how to use this on runtime? Whatever functions we are using, or whatever till now whatever we were using was static memory allocation, and now we are using dynamic memory allocation. Now dynamic memory, as we have discussed, will be having stored memory in heap section, and it will grow upwards. Okay, now what are the functions we will be using? And one more thing is, Okay, so we will be seeing this from your some functions called malloc, cloc, free and valloc. What are the uses and everything we will see tomorrow. But for now, I'll just give you small introduction to this and we will conclude that with small examples. Now I will just use this malloc first. So what is malloc is memory allocation only. Malloc is nothing but memory allocation. What will be the what syntax for it we will see. malloc.c. Now the syntax for this will be void or any other thing, and then you can say pointer malloc, and we will have size underscore t space size. This is the syntax for your malloc. Okay, now we don't know what is the size, so here we can simply write int. Okay, and how many allocations you need? Int 100. So if you want 100, int into 100. So you will be allocated 4 bytes per integer and 100 such particular element. So 4 into 100, 400 bytes of memory will be allocated using this particular function. And one more thing, here this will be allocating your contiguous memory locations. So if at all if there is no space available for this particular thing, at that time it will return null. That means it will return null saying that space is not available for the required memory. Okay. So one example we will see it using your malloc function. Now I'll just remove this and I'll write one function. I'm sorry, I'm not reading it. What I'm doing. Now here I'm writing that I'm taking some pointer. Okay, so I'm taking some int pointer c, and I'm saying that I want to have some memory allocated for this. So I'll write here what was the syntax. First we need to say void or anything. So here I'm writing int. I want integer. I'm not writing pointer. So this is my integer pointer. I write your malloc, and here we need to write the size of. Okay, so malloc size of integer t. So here it will allocate that much amount of memory to your now. Here what we will do is I want to see this. Okay, so how to see this we will see now. Now what I want to see is what is the size of this P allocated. Okay, so here I'll just try to print it percentile t /n comma, here I'll write size of P mostly it should be 8 bytes only, but still we will see. gcc malloc.c error So GCC I have not written. Okay, so we got one warning. So as I expected, we will get only this 8 bytes only. Now we will try to change this to. I want to find out the size of this malloc allocated. So we will do that using pointer p is pointing to this size of an integer, and here I'll write int into 100. And now we'll see whether we are getting it or not. So here also 8 only. So basically we need to assign it. Without assigning, we will not be able to see this value. Okay. So how many bytes of memory has we are using pointer, we are using this, and we can do one thing, and that is even I forgot, I think. Say that we have to print the address, I guess, but that for that we will have to print first address as well as last address. We have to write some more functions. We will do that tomorrow, but as of now I want to do some particular operations on this. Or we have to enter the name or number something. But I want to see the starting address and last address of this. For that we will have to see. Okay, we will for now we will see whether it is allocating that memory or not. Okay, so for that I'll do one thing, that just now we have said that if at all if memory is allocated, it will say us that memory is allocated. If not, it will see us null. The memory is not available. So we will do that thing at least. So here I'll write now if loop, if function, sorry, if my p is equal to null, then what it should do is it should simply print that printf memory not allocated. At least we can say that, see that else memory allocated. We can at least to see this if we are not able to see the address. Okay, so now we are having some 100 bytes of memory which is of integer size. Now integer here is of 8 bytes. That's why we are saying that 8 into 100 is 800 bytes of memory. Whether it is allocated or not, we will just see. GCC with errors before numeric constant we have. Okay, again a typing mistake. error expected. These are warning, that is okay. Here it is just simply showing that add this particular library to use this particular built-in function called malloc. Okay, because malloc is not defined in stdio.h, that's why it is showing us that add this stdlib.h because or provide a declaration of malloc. And we will do that while executing program. But for now, just we will execute. So we need to warning dot slash a dot out. So here memory is allocated. That means our program is allocating some amount of memory. So we will not be able to see it directly, but we will have to use some other functions or other things to allocate it and see. We will do that tomorrow. Why? Because we will need some functions to write. Okay. Same way we have to use cloc also. Cloc is also same, and I'll be able to save you only this much. So better we will do it with examples tomorrow. Yes, that's it. We will be ending today's session. If you have any doubts, you just say me. I'll share you. Okay. Yesterday I didn't share you some programs because I was just preparing some programs. Executed programs I should give you, or just the questions are enough for you that you say me. But topic wise, we have just starting. We have done only generic topic, and now we are going in depth topics of it. So I just stopped to give all the programs in one particular way. So just give me couple of days time. If you don't want your executed programs, just want questions, then also I'll just give it. If not, if executed programs you want, I'll just give that also in couple of days, I think. And I'll just share this recording with you. If you have any doubts, you just tell me.